Hi there. My name is Alan Romano, and I'm a third-year PhD student at the University at Buffalo. I'll be presenting our paper, An Empirical Analysis of UI-Based Flaky Tests. This is joint work with the researchers at the University of Texas at Dallas. I'll begin with the presentation by giving some background on flaky tests. Then, I'll go into the details of the study that we performed. Next, I'll give details on the root cause categories, manifestation strategies, and fixing strategies that we identified. I'll give a discussion on the implications of our findings, and then I'll present the conclusion of our work. Flaky tests are tests whose outcomes are non-deterministic. That is, for the same test and for the same code, different runs can produce different results, making their outcomes unreliable. Flaky tests have been observed in up to 45% of in the studies that looked at them, and up to 16% in production systems. This leads to wasted development time and resources. Most of the work that focuses on flaky tests looks at traditional unit testing. UI testing is inherently different because these tests expect events that are highly asynchronous, such as waiting for user input and API call responses. In addition, layers of complexity are introduced in the input sequences, including interaction between the user and the UI, and between the UI and the test code. For this reason, we perform an empirical analysis of UI-based flaky tests. We investigate 235 real-world flaky UI test samples from web and Android projects. We study the samples along 3 dimensions by identifying the underlying root causes of the flaky test, underlying the conditions in which they manifest, and identifying the typical fixing strategies used. We collect the samples using different methodologies for the web and Android projects. For web samples, we inspect the GitHub commits by identifying the repositories using keywords of popular web UI frameworks, including React, Angular, Vue, and more. We then download all the commits from these repositories. For the Android samples, we inspect the GitHub issues by leveraging the GitHub archive to perform big data searches using the keywords Android, UI, Espresso, and more. In both setups, we search the commit messages for the patterns flake and intermit, as was done in Luo et al. 2014. We then manually inspect these samples to verify that the commit indeed contains a flaky test. In total, we obtained 235 flaky test samples, with 152 of them belonging to 25 web projects and 80 of them belonging to 37 Android projects. As an example of our methodology, here we have a commit from the JetBrains Ring UI project. The commit message here tells us that the root cause of the flakiness is that the image network load can be slow during testing. The symptom is that the avatar image in the tag component won't appear if the load doesn't finish in time. The fix implemented here can be seen in the commit code. The network load is avoided by embedding the image as a base64 string. Now we'll go over the root cause categories that we identified. The first category is async wait, which has been described in previous work. We find that the root causes can be further divided into the following subcategories. Network resource loading issues attempt to manipulate data resources before they're fully loaded, and resource rendering attempt to perform a UI action before the resource has been fully rendered. Animation timing issues are sensitive to the timing differences and animation scheduling. The commit below shows a reporter describing an async timing issue they experience on a continuous integration system. The next category is environment, which includes subcategories like platform issue, where the platform being used causes the flakiness, and layout differences, where different rendering engines produce different layouts that differ from the expected layout. Test runner API issues include incorrect test runner interactions, where the API provided by the testing tools are the ones that contain the issue. DOM selection issues can't select the correct DOM elements due to browser issues or other elements interfering. Finally, we have test script logic issues, where the logic of the test case is at fault. This includes incorrect resource load order issues, where the code that loads some UI resource and then the code that acts on that resource are specified in the incorrect order. This category also includes a few other categories that have been identified in previous work, including time, test order dependencies, and randomness. Now we look at the manifestation strategies. One strategy we observed was that the reporter would specify the platform on which the flaky behavior occurred. In the example below, we can see here that the reporter points to the Chrome 60 as responsible for the behavior. The next manifestation strategy involves reordering or pruning the test suite in order for the flaky behavior to occur in a particular test. Other samples provide code snippets that manifest the same flaky behavior outside of the test suite. Finally, reporters can provide the configuration options that can reliably manifest the flaky behavior. In the example below, the user needs to force the Android device to act slowly. Now we'll look at the fixing strategies used to avoid or minimize the flaky behavior. Some fixing strategies focus on the delays used within the tests. These strategies include adding or increasing the delay between actions and fixing the awaiting mechanism so that the execution is actually paused, as shown in the examples below. Other fixing strategies look at fixing the external dependencies and include fixing incorrect or misused APIs. Another strategy changes library versions to earlier ones that didn't contain the flaky behavior. Other samples refactored the test checks in order to account for the flaky behavior. In the example below, we can see that the strict time comparison is changed to allow an error margin of 5 seconds. Finally, some tests opt to disable features that introduce flaky behavior during testing, such as disabling the animations, as shown in the example below. Now I'll go into a discussion on our findings. In our study, we find that async wait issues tend to be more prevalent in web projects than in Android ones. This suggests that web testers need to be cautious when relying on network or resource loads. We also find that platform issues tend to affect Android projects more than web projects, which suggests that the fragmentation problem that plagues Android must be considered when selecting a testing model. The results of our findings can also be used as a foundation for preliminary ideas on automated fixing strategies of Flaky UI tests. For example, the add increase delay strategy could be automated by identifying typical delaying statements and then increasing the time specified. The fix await mechanism strategy could be automated by identifying incorrectly used async wait statements. Our results also allow us to identify the correlations between the root causes of flakiness and the common fixing strategies. For example, we find that resource rendering issues are usually fixed by adding a delay or fixing the await mechanism. These correlations could be used to identify the appropriate fixing strategy once the root cause of the flakiness is known. Our work is most closely related to existing works that perform empirical studies on software defects, perform studies on flaky tests, and those that propose strategies for automatically detecting and fixing flaky tests. In conclusion, we performed an empirical study on UI tests that contain flaky behavior. We investigated 235 flaky UI test samples from both web and Android projects. We identified the root causes, manifestation strategies, and fixing strategies applied on the samples. Our results provide guidance for web and Android project testing and give insight on possible automated fixing strategies. This concludes our presentation, and thank you for watching.
Hi everyone, welcome back to this Q&A. We are in the Flaky test session. My name is Jose Rojas and I'm your session chair. We have in the Q&A now Alan Romano. He's the lead author of the paper titled An Empirical Analysis of UI-Based Flaky Tests, part of the technical track at ICSI this year. So yes, Alan is very keen to answer your questions. Alan, there is a couple of comments saying that it's a very nice work.
Thank
so
you.
Yes, that's praise for you. And there's already one question by Wing Lam, who says, does testing with animations provide any benefit at all to developers? Doing so seems to slow down testing and it may cause flakiness. But it's unclear what the justifications are for using animations, really.
So through our results, we do find that the animation, specifically the animation timing issues, are a root cause of flakiness. it goes so far as even the Android libraries for testing recommend to disable animations just to prevent flakiness. This does help reduce the flakiness that you see during the test week, but there is also, I guess, if you're not testing it, there's a chance that you'll just pass any jankiness that you experience onto the user side. So that's also not ideal. So that's pretty much the primary benefit, is just to make sure that the animations that you add to your application are working as intended.
Yeah, I guess for end users, animations actually matter, right? As developers, we might think that they are not very useful, but end users prefer, yes, they like them, I guess. We have a question from Shane McIntosh. Thanks for the presentation, he says. Do you believe that there are other types of tests for which flaky tests should be analyzed in details?
So we looked at UI-specific tests in web projects and in mobile projects, but we primarily focused on Android projects. So kind of, I guess, the next extension would be for iOS projects, which we didn't really focus on. And aside from that, I think a good type of test would just be maybe tests that rely heavily on network uses that aren't necessarily web or mobile. So maybe cloud applications that I guess don't have a website for them. But that's I think the asynchronous nature of just networking makes them kind of a primary spot for flakiness to arise.
Yeah, thank you very much. Chanduk asks a very natural question, I would say, as a result of watching your presentation. Could the insights that you provide as a result of your empirical analysis be considered or be built into some form of heuristics for detecting flaky tests?
So yes, that is ideally our main goal for the findings of our study. What we found was that through our analysis of the manifestation strategies, which would ideally be the information that could be used for detecting the flaky tests, we found that the correlations between the root causes categories that we identified and the manifestation strategies, they weren't strong enough to actually be on themselves be used for detection strategies, but the correlations between root causes and fixing strategies that we found were. So the detection part is still an open problem left for future work, and but the fixing strategies could be used to help design preliminary automated fixing strategies.
Absolutely, yes, thank you. Leopoldo Teixeira, he says, very good work, Alan. What would you consider to be the main distinctions between flakiness in web versus mobile testing?
I think the main distinctions would just be that web projects would tend to be a bit more diverse in the running conditions. You have to support the different browsers. The different browsers are implemented for different operating systems, which could have their own particularities that introduce some issue that causes flakiness. Whereas, well, since we looked at Android specifically, there is also the fragmentation of the Android versions, but it's still primarily running on a more or less standard Android platform. In addition, web projects, their UIs are just have to, I think, interact more with the DOM, which might not always be as quick as, I guess, a Java engine creating the UI layout. So there are some issues that arise from that as well.
Mm-hmm. Thank you very much. Any more questions from the audience? While more questions come up, perhaps I can ask one myself. I'm particularly interested in Android apps and testing Android apps. And in my experience, Espresso Test Recorder is often the culprit for flaky tests in Android testing. Did you find in your experiment some intuition or some supporting evidence for this? Could you be able to say that test cases that were produced with Espresso Test Recorder tend to be more flaky?
So we do find that there are some cases where the testing library, like Espresso, are what actually introduce the issues. In our root cause categories, we label those as incorrect test runner interactions, where it's the test suite or test runner at fault. So there are some test cases that we find where Espresso or any testing library is introducing the flakiness.
Does this also apply to testing frameworks for web applications, like, for example, Selenium or Cypress?
Yes, there are cases where the test runner may reach kind of an edge case in a web application where the events that they use to trigger certain actions aren't, I guess, standard events, so they won't necessarily trigger the event that the developer wanted to test. So these are instances where the test runner is kind of introducing the flakiness rather than the actual application.
Did you see the Android emulator causing flakiness?
From what I remember, we did find some test cases where it's just the speed of the Android emulator kind of causing the more noticeable animation timing differences that ultimately lead to the animation timing issues.
I think that's very related to the next question that Marcelo is asking, whether you can distinguish between flakiness due to the cost of running tests as opposed to the fact that they actually are manipulating the user interface.
So it's as opposed to we kind of focus more on whether the test has a UI component to it. We didn't really analyze whether this was a result of the actual, I guess, interaction part of the test, or whether it's more just the resource usage of the test.
Yeah. Perhaps you can follow up with Marcelo, because I'm pretty sure that Marcelo has a follow-up to this question. Thank you very much, Alan. Very nice work and very nice presentation. And thank you, everyone, for attending this session on Flaky Test. Enjoy the rest of your conference, and I'll see you around. Thank you very much, Alan.
Thank you so much.